The coin change problem is a classic algorithmic problem in computer science and dynamic programming. The goal is to determine the minimum number of coins needed to make up a given amount of money, using an array of coin denominations. If it is impossible to form the amount with given coins, the algorithm typically returns -1. It is an excellent example to illustrate dynamic programming. The problem can be solved either top-down, recursive approach with memoization, or bottom-up, iterative approach, aka tabulation. Here will be demonstrated the bottom-up iterative solution. Anyway, let's take a look at how it works. One remark: in no way am I the author of this algorithm. I just took the well-known solution and rewrote it for JavaScript. There is no HTML structure and no CSS, only an embedded JavaScript. Console log will do the output, and a bit later I will use the alert box to show the algorithm in slow motion. The coin change problem is solved by one function, coin change. This function has two parameters: the coin denomination array of given coin denominations, like 1, 2, 5. The target amount to make up. In this example, it will be 11. This function creates an array number of coins of size amount +1. +1 because we need to include base case 0 for 0 amount. Fills it with infinity to represent that initially all amounts are impossible to make. Sets up the base case because 0 coins are needed to make the amount 0. Outer loop builds up solutions for all amounts. Iterates over every amount from 1 to amount inclusive. For each sum, we compute the minimum coins needed to make it. Inner loop try every coin denomination. For each sum, check every coin in the coin denomination array to see if it can contribute to the solution. You can't use a 5 coin to make up a sum 3. Next comes the key step in this algorithm. We update the number of coins at index sum to the minimum between its current value, infinity, or a previously computed minimum. 1 plus number of coins at index sum minus coin. 1 is for using the current coin plus a solution for the remaining amount, and that solution is already computed, since we are building solutions bottom up. The ternary operator returns either -1 if the solution doesn't exist, or the number of coins needed to make up the target amount. Now I want to show you how to use an alert box and console log to pause the algorithm inside the inner loop and display the current state of all variables. That's it. I added console log to display the number of coins array with the spread operator applied. On the next line, alert box pauses the program in real time and displays the names and values of all variables at the current iteration. Look. You can see how it builds up the number of coins array step by step, bottom up. Before I say goodbye, last one thing. Here is the variation where the function coinChange returns not the number of coins, but the array containing these coins. Look. The output is the array 1, 5, 5, as expected. These are the changed coins for the target amount 11. There are a lot of comments in the code to explain everything, so I leave it to you to figure out how the last variation works. That's all for now. Have a nice one.